On 14th of June 2020, on the Belgrade bypass, which is a part of the international route Corridor 10, the Public Enterprise Roads of Serbia completed all works on the construction of the bridge over the river Sava at Ostruznica as part of the second phase of the construction of the ring road encircling the capital. A twin bridge, practically the left structure of the bridge in the total length of 1,963 meters, was opened for traffic that day. The bridge over river Sava at Ostruznica is the largest structure on the Belgrade bypass and is one of the most significant infrastructure objects on the territory of the Republic of Serbia regarding size and importance. A separate bridge structure has been constructed for each lane of the motorway, while obeying the requirements of the phased construction. The distance between the upstream and the downstream side of the motorway, the median strip, is 4 meters, and the clear distance between the carriageways is 2.3 meters. The traffic profile on both carriageways is the same, consisting of a carriageway with 3 traffic lanes in the total width of 11.5 meters, a shoulder, and an inspection path in the net width of 0.75 meters in the entire length. The inspection path is at the same level as the carriageway, separated from it with a protective steel barrier. The total width of the carriageway slab between the edge beams is 13.6 meters. The bridge consists of pre-stressed concrete access structures on the left and the right bank of the river Sava. The structure from the Surčin side is 592 meters long and has 16 spans, while the structure from the Ostruznica side is 784 meters long and has 23 spans, a crossing slab, and 4 spans on the crossing over the road Obrenovački put. These two entities are connected by a continuous steel structure over the river Sava, consisting of 5 areas in the length of 586 meters, with the largest span over the defined waterway in the length of 198 meters and weighing 4,500 tons in total. The design originally predicted a free assembly of the 56 segments using a floating crane and temporary support on piers on the riverbed. After the high-resolution magnetic survey of the riverbed, due to the potential presence of unexploded ordnance on the Sava riverbed in the bridge zone, this assembly technology had to be abandoned as a risky one. After reviewing new solutions in order to avoid sinking of yokes into the riverbed, while striving to preserve the largest part of the already constructed steel structure, the new technology predicted the combination of 3 methods of assembly as the most optimal one. The longitudinal launching over rails using hydraulic jacks on the tugboat. 2 spans in the length of 187 meters had been pre-assembled in the riverbank. After that ensued the procedure of free assembly of segments on central piers S1, S2 and S3, and the lifting of 3 segments of the structure, each 77 meters long and weighing around 550 tons, which had been turned into a vessel in the shipyard in accordance with the naval engineer's design, and then launched and tugged to Ostruznica, where they were lifted and assembled using derrick cranes. All wisdom, knowledge and skills, supported by the experience and engineering assurance, have been applied in the perfect triangle, designer, contractor, supervisor, so that the new bridge would grow and connect the banks of the river Sava. The first significant venture was the longitudinal launching, or the pushing of a part of the structure from the pre-assembly plateau towards the pier S4, weighing 1,000 tons. The beginning of the assembly took place on a scaffold between the piers S6 and D3. The scaffold was long enough to put together 8 segments in total. The launching was performed using pre-stressing cables and hydraulic jacks, having placed the pre-stressing cables under the lower area of the bridge box, where the passive end of the cable was anchored in the pier S6 using adequate tools, while the active end of the cable and the hydraulic jacks which performed the launching were supported by the edge of the structure used for the launching. The thrust force was accomplished using hydraulic jacks, which had been moved together with the structure, while the cables remained all the time under the structure and were not moved. This procedure was divided into 4 phases. The first was launching 45 meters long segments incrementally, without a floating support. The second phase designated the pushing of a 43 meters long segment with the use of a floating support to the pier S5. The third stage saw the pushing of a 44 meters long segment incrementally and without a floating support, and the fourth phase consisted of the pushing of a 55 meter long segment with the use of a floating support to the pier S4. The second significant venture was the lifting of 3 steel structures. The method of lifting the segments of the bridge structure was foreseen for the spans S1 to S2, S3 to S4, as well as the last phase of assembling the segments of the central span between the piers S2 and S3. These sections, 77 meters long and each weighing approximately 550 tons, were joined together at the shipyard located 10 kilometers upstream from the bridge location. Having joined the segments together and applied anti-corrosive protection of them, and after the taking over of works by the supervisor and the competent naval authorities, the segments were launched into the river in the shipyard area. The transport to the construction site was done using tugboats and pusher boats, while the lifting was performed by the derrick cranes and hydraulic jacks in several steps. The first step was raising a part of the bridge structure by force on hydraulic jacks for lifting, each having a bearing capacity of 200 tons, with a piston stroke of maximum 250 millimeters, until the supports have been activated. The second step was lifting the structure until it has emerged from the water. The third step foresaw the lifting until a complete segment of the bridge has emerged from the water, after which the structure was dismounted in order to provide buoyancy. The fourth step saw the lifting of a segment of the bridge structure using hydraulic jacks to the designed position. Prior to the commencement of the finishing work, edge beams and inspection gantries had been installed, and then a guarding rail was installed. Waterproofing was performed, pavement was constructed, and a crash barrier was installed, thus completing the construction of the bridge structure. Such combined method of construction of steel bridge, with several different methods and segments 77 meters long, represent a unique, unusual, and extraordinary endeavor which had never and nowhere been applied before. The construction of this bridge required, like never before, fulfillment of natural conditions. Restricted to work only from the water mirror of the river Sava and its whims, the rising and falling of its level, and the speed of its flow, faced with the wind speed, air temperature, traffic flow from the neighboring bridge, through constant monitoring, control and engineering knowledge, institution and skills, the banks of the river Sava were connected. Patiently, with good management, experts of the public enterprise roads of Serbia, together with the construction workers engaged on the construction, have accomplished a major construction feat for the benefit of their country and to the delight of users. The twin bridge has soared over the river Sava at Ostruznica, and the extraordinary construction endeavor has been left as a legacy for the future engineers and bridge constructors, as a proof that things which were hard to believe in can be accomplished. The bridge in the length of 2 kilometers has been constructed without touching the ground, and that's something to be proud of. With the completion of the bridge number 8, the Belgrade bypass has become functional as a full motorway profile in the length of 26.9 kilometers, from Batajnica to the interchange Ostruznica.